Very good morning, dear students. In the previous lecture, we have seen the exercise which is composed of the topic that is permutation under restriction. Okay, and in that we have seen that is permutations when all the objects are different. Okay, in that we have seen some theorems. Okay, and we have done the questions related to the same. But now we are going to head to the next exercise, that is permutations when all objects are not different. Till now you are seeing that say for example I'm taking one word that is from randomly, that is say for example Sachin. So you see in this all the objects are different. There is no repetition in it. Now if I write, say for example, if I write a word that is examination. So as you can see that in this two A's are coming, two I's are coming, and even you can see N's. So such type of case or situations we will be seeing in it. Okay. So when the permutation, when all objects are different, we can easily find the total number of ways or the arrangements we can do in that particular thing. Now when the all objects are not different, then what is the formula for it? That is very easy. We'll see it in the question itself. Okay. Now let us take this question only of examination. And the question says, like, find the number of permutations of the letter examination. So how we will do it? So as I told, this is the case when all objects are not different. So first let us see how many things are repeating. So we have two A's, two I's, okay, and two N, and anything else? No. So what are the rest? E, X, M, T, O, okay, 2, 4, 6, 8, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Correct. Now how we will do? There are total 11 letters. So 11 factorial upon how many things are repeating? 2. So 2 factorial into 2 factorial into 2 factorial. So this is what the formula says, that if you have n objects, so find the n factorial divided by how many things. That means when p object are alike, q objects are alike, r objects are alike, then you take the factorial in the denominator, that is p factorial into q factorial into r factorial. And the same we did in this. We have counted the letters, that is 11 factorial upon how many things are alike. We have taken the factorial in the denominator and divided with that. So this is the process we'll follow in the exercise. Okay. Okay. So here one game we are going to play. Okay. I hope you are ready for it. So see. This is say for example you consider a ground, or you say that you think this is a bhul bhulaiya kind of. Okay, this is your starting point and this is your end point. You have to reach here. Starting from here you have to reach here, and the condition says that you can take only a right step or an upward step, which means you have to go in this way. Okay, you don't have to, if you move, if you walk, if you started walking here, you walked up, then you can't be back, or you should not take a left turn. You should be straight, either up, either right, upward, right, upward, right, upward. This should be your way. Actually I'm clearing the conditions that you have to keep in mind. Not necessarily in the same, like 2 rights, 1 upward, 2 rights, 1 upward. No. You can go in any order, but it should be right and upward, right, upward, upward, right, right. So like this you have to go. So you need to determine how many numbers of paths are possible to reach from the starting point to home point. Okay, so as we count we can count that 1, 2, 3, 4, 5, 6, 7, 8. There are total 8 steps, because if you go with any of the path, say for example I'm going like this, 1, 2, 3, 4, 5, 6, 7, 8, then also 8. Any path if I follow, 1, 2, 3, 4, 5, 6, 7, 8, total 8 paths will be there. Okay, in which I need to take 4 right steps and 4 upward steps also. Okay, are you understanding? Whether no matter whatever path I chose, I have to take total of 8 steps, and from that 8 steps my 4 steps will be definitely a right step and 4 will be the upward steps. So this is what, see, 8 factorial upon 4 factorial into 4 factorial. Why? Because this is the condition of permutation when all the objects are not different. Why not different? Because 4 steps are to be taken as right steps and 4 steps are to be taken as the upward steps. So by doing 8 factorial upon 4 factorial into 4 factorial, we are getting answer 70. And 70 are the ways in which you can start from here and end here. Are you understanding? So such type of applications we have to use in this. Alright, coming to some questions of the exercise. In how many ways can 4 red, 3 yellow, 5 green discs be arranged in a row if the discs of the same colors are indistinguishable? So 4 red, 3 yellow and 5 green. Total it is 12 discs. So 12 factorial upon 4 factorial into 3 factorial into 5 factorial, simple. Okay. So total, because how can you arrange if the colors are indistinguishable? Same colors are indistinguishables. So there are total 12. So 12 factorial upon 4 are alike, 3 are alike and 5 are alike. So, by this we have to do. Okay. Find the number of arrangements that can be made out of the following letters. Banana. How can we? 1, 2, 3, 4, 5, 6. 6 factorial upon how many are repeating? 3 A's are there. So 3 factorial into 2 N are there. 2 factorial. By this you will get your answer. Okay. Pineapple, institution, civilization, apple, root. They are easy to do. Okay. Okay, coming to the next question. In how many ways, in how many different ways the letters of the word algebra can be arranged in a row if 2 A's are together, the 2 A's are not together? Okay, now there is condition also that 2 A's should be together. Okay, so algebra, 2 A's are together, A should be together. So make 2 A's a one block, one unit. You are left with L, G, E, B, N, R. Now, how many letters are there? 1, 2, 3, 4, 5, 6. 6 factorial, that is 720 ways will be your answer. Okay, because we need to find the arrangements which we can make, the different ways the letter, this can be arranged when 2 A's are together. So these 2 A's are together. So we are taking as one block. So 1, 2, 3, 4, 5, 6. So 6 factorial is what? 720. So there are 720 ways. Okay. Now, when 2 A's are not together, you know, in this full chapter, one thing you always remember, that whenever you are asked with if this does not occurs, okay, 2 A's does not together, are not together, sorry. So first you find the total ways and you subtract with which can happen. As we have already calculated the 2 A's together, so that is 720. Okay, you just try to find how many total possible ways could be there. So 1, 2, 3, 4, 5, 6, 7 upon 2 A's are there, so 2 factorial. This will give you the total number of ways. of arranging the letter. So 7 factorial upon 2 factorial is 7 factorial divided by 2. Okay, the answer is, 7 factorial divided by 2. The answer is 2520. So this is the total number. Now, two A's are not together, so 2520 minus the comes. This is similar to the probability. You know, we do in probability, right? To find the probability of not happening, we subtract 1 minus probability of happening. That gives us the probability of not happening. So similarly, not happening, first of all, the total, what is the total? This minus the happening. So 2520 minus 720, this is 1800 ways. So total 1800 ways where A will not be together. Okay. Coming to the next question, how many different numbers can be formed out of all the digits of 1, 1, 1, 2, 2, 3? Okay. How many of these are greater than 3 lakh? 1, 10, 100, 1000, 10,000 lakh. Okay, 3 lakh. So how many different numbers can be formed out of this digit? How many numbers we can make? So there are total 1, 2, 3, 4, 5, 6. So total 6 factorial upon how many are alike? This 3 are alike. So 3 factorial. This 2 are alike. So 2 factorial. 6 factorial is 720. 3 factorial is 6 into 2. So 720 divided by 12. This is 60. So 60 numbers we can form with the help of this digits. How many of these are greater than 3 lakh? So it should be greater than, from this 1, 1, 1, 2, 2, 3, we have to make a number which should be greater than 3 lakh. So we have 3. So on this position we are fixing 3, that in this position 3 will be fixed. Now we are left with this 5 positions and this 5 things. So the total 5 factorial upon how many are alike? 3 factorial into 2 factorial. This is 120 upon 6 into 2, 12, 10. So 10 numbers will be there. So like this we will do. Okay. Coming to the last question of the exercise, how many arrangements can be made with the letter of the word mathematics? So with the mathematics, how many letters we can make? So first question is, there is no restriction. So there is no restriction. That is very easy one. Just count all the alphabets of mathematics and divide it by what all alike. That means how many A's, M's are repeating, divided by the factorial of them. Vowels occur together. How you will do vowels occur together? As I've done one question, make all the vowels one block and find the factorial of it. When all vowels does not occurs, again I told you regarding this, total minus vowels occur together. Consonant occur together, so make all the consonant as one block and just those vowels another thing. Okay, and then use the concept of this formula. M is at the both extreme positions. Now both M, you fix both the M on the extreme position. In that between, just count the number of positions divided by how many things are repeating. And for the sixth one, order of the vowels remain unchanged. The order, that means you need to fix the positions of vowels, whatever given in the mathematics, just fix the positions of the vowels and you circulate all this. See, the hint is also provided to you in the question itself. Alright, so try to do this exercise and I request you to solve each and every example in the copy of this exercise. Okay, you will get a very good understanding and idea of this exercise. Okay, and let me tell you one more thing. Circular permutation is exempted in the reduced syllabus of 2020 and 21 examination. So we won't be doing this exercise. We will be directly seeing the combinations in the next lecture. Okay, so I hope permutations were quite easy for you, or maybe for some students it is somewhat challenging. So you know, this chapter requires a flow and a good practice. So I expect the same from all of you. Thank you so much. Have a nice day. Bye bye. Thank you.